So block 3 is about the wave. First thing is the definition of a wave, how you define a wave. So definition of a wave is basically a wave transfer energy from one place to another. If we transfer energy, if we transfer disturbance from one place to another, the way by which this is transferred, what we call that as a wave. So the disturbance move along the wave, not the particle. Example, like here you observe the water waves, but when we compare these particles, like example, if I say the particle of the water or H2O molecules, so how these particles will move? These particles will move, actually these particles are not moving from one place to another. These particles are vibrating up and down, and they are transferring energy from one place to another. So the idea of a wave, so the disturbance in the molecule of a water, it's going up and down, and water is a medium, it's transferring the energy. So example, if I say these are the particles of the water or water particles, so what happened? So in this, the first example, the particle are disturbed, particle are moving up and down, and they're transferring energy towards right hand side. In the next example, in terms of particle, when we compare the movement of the particles, so you can see here, the particles are moving up and down. So this is the disturbance of the particle. Either they're moving up or they're moving down. But what is the transfer of energy? The energy actually travels from one place to another. So the mode of energy transfer, the way by which energy can transfer from one place to another, we call that as a wave. So definition of a wave, the mode of energy transfer, and how we can produce wave. There are two types of waves. One is known as longitudinal wave, another one is transverse wave. So wave motion or explanation of a wave. A wave transmits energy from one place to another. For example, energy can be carried by water wave generated by the boat outside, out at a sea shore, or sound waves from a loudspeaker to an audience here. So example, if you have a container and you fill this container with water, and you place a wooden object at point B, or you place a piece of wood at this point. Now, example, you have a ruler or a scale, and you put this ruler or a scale, or immerse this ruler or a scale in water, and you start to move this ruler or the scale up and down. So when you start or move this ruler up and down, what it will produce? It will produce a wave. So wave will travel from ruler to the wooden object, and what we will observe, without any contact between the ruler and the wooden object, this wooden object will also start to vibrate or start to move up and down. So as this wooden object start to move or vibrate up and down, so what it shows, it shows that the energy is transferred from one place to another. So the water molecule, because the movement of the water molecules or water molecules move up and down, and without any connection, like You don't have any contact. This object is not having any contact with a piece of wood. But what you'll observe a piece of wood also start to move up and down. It means there is some work done, or there is some energy transfer from the ruler to the wood. And how this energy transfer? This energy transfer in the form of wave. So basically, a wave transmit or transfer energy from one place to another. Then there are different types of waves. Is it clear, the concept of the wave? The mode of energy transfer, the way by which you can transfer energy from one place to another. Then there are different types of wave that we'll discuss, but the first thing is the concept, the way by which energy transfer from one place to another. Then there are two types of waves. One is called a transverse wave, and the second one is known as longitudinal wave. What is a transverse wave? Example, you have a string. And this string, you fix one end of a string. Or a wire, and you're catching the other end. This is a piece of wire. Or a string. If this red shade is representing the particles in the wire or particle in the string, so example, you have this red shade is representing the particles, and you are holding end A. You're holding end A, and you start to move this end A up and down. So when you start, or when you move this end up and down, what you will observe? You will observe a wave. And when you observe this wave, what will be the new position of this particle? Originally, example, if I say this was particle 1. So what is the new position of particle 1? The particle 1 will be at the top. If this was particle 2, what will be the new position of particle 2? The particle 2 will be down. So particle 1 moving up, particle 2 move down. So which direction the particles are moving or particles are vibrating? So particles are actually moving up and down, or this is a movement of the particle. And what is the direction of the energy transfer? So what is the direction of the energy transfer here? The direction in which the energy travel from, because the energy travel from point A to point B. So direction of energy transfer. How the particles are moving, we are causing a disturbance. We are holding a string or a wire, and we are causing a disturbance. We are moving a string up and down. So as we move the string up and down, so what we will observe, the position of a string changes. As the position of the string changes, the position of the particles will also change. So as we are moving the string up and down, we produce a wave, we transfer the energy, but the particles move up and down because we are causing this movement. So particles are moving up and down, and the direction in which the energy transfer from A to position B. So if energy transfer is towards right in this example, how you can identify direction of energy transfer is towards right? If someone is holding this point, if someone is holding a string at point B, he can experience the force or he can experience the energy. That is why the direction of energy transfer is towards right. So if direction of the particle is up and down, and the direction of the energy transfer in this example is towards right. So what is the angle between the direction of the movement of particle and the energy transfer? This is a wave direction in which the wave travel, and this is a direction in which the particle move. So particles are moving up and down and the wave is traveling towards right. So the angle between the particles and the direction of wave is 90 degree. So when angle between that particle movement and the direction of wave is 90, what we use the term perpendicular. So a transverse wave is in a wave in which the vibration of the particle is perpendicular to direction of the wave. And to remember this, the T transverse is starting with T. So when I write this letter T, you can see the angle for the letter T is 90. So it's easy to remember. If it's a transverse wave, then the angle between the direction of the wave and the direction of the particle is always 90 degree. Look, I'll repeat. Example, you have a string or a wire, and you're holding at position A and your friend is holding at position B. Now you start to move this string or a wire up and down. So as you start to move this wire or a string up and down, your friend will also experience the force. Why the friend will experience the force? Because the energy transfer and how the string will move, what you will observe, the vibration of a string. It will appear the string is vibrating in this manner. So when you check the movement of the particles, which direction the particles are moving, so if this was particle 1, 2, 3, 4, 5, 6, and 7. So which direction particle 1 moves? What is the direction of new position of particle 1? When you start to disturb or produce disturbance at A, which direction the particle 1 will move? So particle A1 is moving up, particle 2 is moving down, particle 3 moves up, particle 4 move down, 5 move up, 6 move down, and 7 move up. So what is the direction of the particles? So direction of the particles, either the particles are moving up or they are moving down. Now, in which direction the wave travels? So what is the direction of the wave? Because you produce the energy and your friend is receiving that. So the direction of the wave is from left to right. So direction of the wave is from left to right. So what is the angle between the direction of the particle and the direction of the wave? You can mention east, west, north, south, but in this example, it is towards right according to with reference direction. So what is the angle between direction of the particle and wave. So particles are moving up and down. And the wave is traveling towards right. So the angle between them, the direction in which the wave travel and direction in which the particle move, that is 90-degree. Whenever the angle between the direction of the particle and the direction of the wave is 90-degree, what we call that wave as a transverse wave. Is it clear, the definition of a transverse wave? Salman, just a minute, I will show. The particle can move, the first particle can move up or it can move down, but the energy transfer is towards right, so angle between them is 90 degrees. If particles are not representing the wave, the particle transfer energy, and that energy transfer is refers to wave. Collectively, yes, particle will make a wave. So in this example, see, you have a string, you attach a string to one end and the other end is in your hand, and you move your hand up and down. So when you move your hand up and down, so what wave pattern you will observe? You will observe wave pattern like this, in which the particles are either moving up or down. So a wave transmit energy from one place to another, and this energy can be carried by water waves generated by the board. This is an example given. I will show you the water waves as well, how the energy transfer by the water waves. So you can see here, these are the water waves. So they're transferring energy from one place to another. But when I say what is the movement of the particle or disturbance of the particle, so if this is a particle, so if I represent the movement of the particles, so the particle, if I say A, B, and C, these are the particles. So which direction these particles are moving? Either they move up or down, but the energy transfer from one place to another. Yes, the energy is transferred towards the right hand side. Another example, so you can see here in this example, the particles are actually using the energy and they're moving up and down, and some part of energy they transfer. So when you check the movement of these particles, so the particle moving up and down, so, and the direction in which the energy transfer is towards right. So this is example of a transverse wave in which the particle moving up and down, where the energy transfer is towards right hand side. We'll discuss the concept of frequency. Which one you think is transferring the highest amount of energy? 1, 2, or 3? Which wave? The first one, second, or the third one? Which wave is transferring the highest amount of energy? The second one is transferring the highest amount of energy because there are more vibrations. So greater the number of vibration, greater the transfer of energy. The direction of the wave can be towards right or it can be towards left. We should know the source from where it is produced. So you can see the second picture, the vibration is too fast, so which shows greater amount of energy is supplied. And here for water, you can see the water particles. The particles are moving. The term frequency I will explain, but first I'm explaining the idea that the least one was a third. And the third one, the least minimum amount of energy supplied. So the wave are carrying energy from one place to another, but the water particles are not transferred. The water particles are actually moving up and down and they transfer energy from one place to another. Is it clear, the concept of transverse wave? Any doubt in this? So first kind of wave is called a transverse wave, in which the particles are moving perpendicular to direction of the wave. The second kind of wave is known as longitudinal wave. Longitudinal wave means in which the particles vibrate parallel to direction of the wave. So example, this is a speaker cone and these are the air particles. This hole is representing the particles of the air. So what happened? If we make this speaker cone vibrate, this speaker cone will collide with the air particle. When it collides with the air particle, so it pushes the air particles in the direction. So you can see the speaker cone is pushing the air particles. So which direction the particles are moving? So particles are vibrating, so either they're moving towards right or they're moving towards left. You can see here the particles are either moving towards right or moving towards left. So direction of the particles, it's left and right. And what is the direction of the wave? Just 2 minutes, I will be back. 2 minutes. So the particles here are towards right and left. And if I say what is the direction of energy transfer? So direction of the particle is towards right and left. What is the direction of energy transfer? Or direction of the wave? Yeah, that's right. The direction of the wave is towards right because, like example, if you are using a speaker, when you use a speaker. So speaker transfer energy, that's called a sound energy. And if you are standing at position A, so you'll receive that sound energy. So direction of the energy or the direction of the wave is same as the direction of the particle. So if direction of the wave and the direction of the particle, in this example, it's towards right. Why the energy transfer is towards right? Because a speaker will produce a sound and you will receive that sound. So speaker produce sound and you're receiving it. So direction of energy transfer or the wave is towards right, and the direction of the particle is right and left. So what we can say, because their directions are same, so we can say direction of the particle and the direction of wave is same, or we can say they are parallel to each other. So when the direction of the wave and the direction of energy transfer, direction of the particle and direction of the wave are same or parallel to each other, that kind of wave, what we call that as longitudinal wave. So there are two types of waves. One is called, look, if you have a speaker, these are the air particles. Okay, when you switch on this speaker, or speaker is producing a sound. So how the speaker produces a sound? The speaker cone vibrate, the membrane of the speaker vibrate. So when this membrane vibrate, it collide with the air particle and it cause movement or the motion to the air particle. So which direction the air particles are moving? So air particles are moving right and left. And which direction the wave is traveling? The wave is traveling towards right. So direction of the particles and the direction of the wave is same, or we can say they are parallel to each other. So if direction of the wave the particle movement, it is known as longitudinal wave. So when directions are same, what we call longitudinal, but if direction is perpendicular, we call that as transverse. In a transverse wave, what was the direction of the movement of particle? So you can see particles are moving up and down, and the energy transfer towards right or towards left. So particle moving up and down, and energy or the direction of the wave is towards right or left. So it's 90-degree. We call that as transverse wave. This kind of wave is transverse. But the other kind of wave in which the particles are moving parallel to direction of the wave, you can see here, the particles are moving parallel to direction of the wave. Parallel means the same direction. Like you can see the direction of the particle is towards right, and the direction of the wave is also in the same direction. So when they are same direction, what we call this term? We call they are parallel to each other. And this kind of wave, or this type of wave, when they are parallel to each other, we call that as longitudinal wave. Both are progressive means both can transfer energy from one place to another. So both are progressive waves. So is it clear the difference between the transverse and the longitudinal wave? So example, if I have a spring and the spring is fixed from one end and I'm holding the other end and I move the spring up and down, which kind of wave I will produce here? When I move the spring up and down, so because the particle movement in the direction of the wave will be perpendicular, so it will be transverse. But if we have a spring and I'm pushing the spring towards right hand side, which kind of wave I will produce? In that case, we will produce a longitudinal, because right now, if I say that movement of the particle is towards right and the movement of wave is also towards right. But in the previous example, the particle either move up and down and the wave travel towards right hand side. So the second example is a longitudinal wave. Everyday examples of the wave, such as light waves, water waves, sound waves, in which light waves are transverse, water waves are transverse, sound waves are longitudinal. Microwaves, there are many examples, radio waves, microwaves. You will learn about these waves in detail, but first thing, yes, infrared or heat radiation are also transverse waves. You will learn about these waves later in the chapter, but the first thing is you should understand the difference between the transverse and the longitudinal wave. So for a transverse wave, the highest points are crest, the lowest points are trough. The distance between two successive crests is known as wavelength, or the distance between the two successive troughs is also known as wavelength. Or length of the one wave, like this is one wave, one crest and one trough, one complete crest and trough. This total length is also known as wavelength. And its SI unit, because it is a length, so SI unit is meter, and it is denoted by a Greek alphabet lambda, means inverted Y, it's a Greek letter.